Today, we are going to discuss how to derive the formula for initial decision parameter P0. In Bresenham's line drawing algorithm, there is a parameter P0, initial decision parameter P0. Let us see how to derive the formula for that initial decision parameter P0. Okay. Now, in this derivation, we are going to consider lines that have positive slope less than 1. So we will be dealing with only lines having positive slope and that too less than 1. Okay. So by applying Bresenham's line drawing algorithm, you can actually find the pixels to be plotted. So we need to display a line, right? For displaying the line, we need to find out which all pixels should be plotted. Or we need to find out the coordinates of the pixels along the line path. So for that, we will be performing sampling at unit X intervals. Okay, what do you mean by sampling at unit X intervals? For example, imagine that you are plotting a pixel who's having coordinates 9, 4. You're plotting a pixel whose coordinates are 9, 4. Then, what will be the coordinates of the next pixel to be plotted? The coordinates of the next pixel to be plotted will be 10, something. My point is this, the X coordinate you can predict because X coordinate will always increment by 1 during each step. Okay, I'll give another example. So the first pixel was 9, 4. The next pixel to be plotted will be 10, something. What about the third pixel to be plotted? It will be surely 11, something. That means you can predict the X coordinates of the pixels to be plotted because the X coordinates are incrementing in unit intervals. The X coordinate values are incrementing by 1 at each step. So in Bresenham's line drawing algorithm, you can actually predict the values of the X coordinate of the pixels to be plotted in each step. So if the if the first pixel to be plotted had coordinates 9, 4, then obviously the next pixel will have coordinates 10, something, and the third pixel to be plotted will have X coordinate 11. Y coordinate you can't predict. Okay. So that is the point. We will be sampling at unit X intervals. Okay, so while applying the algorithm, we will start from the left end. The left end, we know that a line has a left end and a right end point. There are two endpoints for a line, left end point and the right end point. So we will start the plotting from the left end point, which is x0, y0. Okay, and then we have to determine the remaining pixels along the line path. Okay, and we have to reach the right end point. So we always start from the left end point x0, y0, and then we determine the intermediate pixel positions, and finally we will reach the right end point. Okay. Now, one important point. Imagine that we have plotted a pixel at xk, yk. So we have plotted a pixel at xk, yk. Now my question is this: what will be the coordinates of the next pixel to be plotted. One thing we are sure, the x coordinate of the next pixel to be plotted will be xk plus 1. That is 100% sure. If the current pixel to be plotted is, if the current pixel that was plotted was xk comma yk, then the next pixel to be plotted will have an x coordinate xk plus 1. That is 100% sure. But what about the y coordinate? Y coordinate can either be yk itself, or the y coordinate can be, yk plus 1. So y coordinate you cannot say. The y coordinate of the next pixel to be plotted can either be yk or it can be yk plus 1. But x coordinate you can say, x coordinate will be xk plus 1. Okay. So the point is this, if the current pixel that was plotted is xk yk, then the next pixel to be plotted will be either xk plus 1 comma yk, or it can be xk plus 1 comma yk plus 1. So there are two possible options for the next pixel to be plotted. It can either be xk plus 1 comma yk, or it can be xk plus 1 comma yk plus 1. Now which one to select? You have two options. Either you can plot this one, or you can plot this one. So which pixel to plot? That depends on which among these two pixels are close to the line path. If xk plus 1 comma yk is closer to the line path, then the pixel xk plus 1 comma yk will be plotted. Else, if the pixel xk plus 1 comma yk plus 1 is closer to the line path, then that will be plotted. So we have to compare the distance of these two pixels from the line path, and whichever is closer to the line path, that particular pixel will be plotted. So if the current pixel was xk yk, you can either plot xk plus 1 comma yk or xk plus 1 comma yk plus 1 as the next pixel, and that depends on which among these two pixels are closer to the line path. Okay, now for that we need to determine d1 and d2. We have to calculate the distance. I said that we should find out which among the two pixels are closer to the line path, and for that we need to find out two distances, d1 and d2. D1 and D2 we have to find out. Now, so in this diagram, you can see a line here. You can see the line here. This is a line to be plotted. So yes, this is the line to be plotted. Okay, that is very clear from the diagram. This is the line to be plotted. Okay. Now, imagine that this particular pixel is already plotted, and the coordinates of this pixel was xk comma yk. So this particular pixel is already plotted, and the coordinates of this pixel is xk comma yk. So now what? Now we have to determine what will be the coordinates of the next pixel to be plotted. And the next pixel to be plotted will be either xk plus 1 comma yk, that is this pixel, or it will be xk plus 1 comma yk plus 1, which is this pixel. So we have already plotted the pixel xk comma yk. The next pixel to be plotted will be either xk plus 1 comma yk, that is this pixel, or it can be the upper pixel, which is having the coordinates xk plus 1 comma yk plus 1. Okay. Now, so which one you will choose? Which one you will choose? Or which one to plot? Which among these two pixels to be plotted next? For that, we are calculating two distances, D2 and D1. So we are you can see at the right end you should calculate D2 and D1. Okay, and D1 is this distance. D1 is the distance between yk and y. What is y? Y is, you can see a point here. You can see a point here. I've marked in red. That point is on the line. Okay, and this red point's x coordinate will be xk plus 1, and the y coordinate be y. Okay, so we need to find out d1 and d2. So what is d1? D1 is actually distance between y and yk, and d2 is the distance between y and yk plus 1. Okay, so we have to find out d1 and d2 and then compare it. Whichever is smaller, whichever is smaller, that particular pixel is to be plotted. For example, in the diagram, it's very clear. D2 is smaller. So the next pixel to be plotted is the upper pixel, which is having the coordinates xk plus 1 comma yk plus 1. That means we have to plot this pixel next, because that pixel is more close to the line path. So just make the comparison between D1 and D2. Whichever is smaller, that will determine which pixel is to be plotted next. So, okay, now one more thing. This particular point you can see here, this particular point has x coordinate x plus this particular point here. You can see a point here. This particular point here has x coordinate xk plus 1 and y coordinate by. Okay. Now we need to determine what is the value of y. Okay, for that we all know that the equation of a line is y is equal to mx plus b. The equation of a line is y is equal to mx plus b. Okay. Now, at this point, what is the x coordinate? X coordinate is xk plus 1. So in this equation, instead of x, if you substitute xk plus 1, then you can find the value of this y. So y is equal to m xk plus 1 plus b. Okay, m is the slope of the line and b is the y-intercept of the line. So So our aim is to find out the value of this y. Okay. And at this point, at this particular point marked in red, the x coordinate is xk plus 1 and y coordinate is y. So we can substitute instead of, we know the equation of the line is y is equal to mx plus b. So in that equation, instead of x, you substitute xk plus 1, and then you will get the value of y. And y, you will get it as m into xk plus 1 plus b, where m is the slope of the line and b is the y-intercept. Yes, so yes, from the diagram, the y will be this. In the diagram, the y will be equal to m into xk plus 1 plus b, where b is the y-intercept and m is the slope of the line. And what is the equation for slope of the line? Slope of the line, m is equal to delta y by delta x. Okay. So in the previous diagram, y will be equal to m into xk plus 1 plus b. Okay. Now, what is d? Let us find out what is d1 and d2. From the diagram, it's very clear. d1 is y minus yk. And we know y is m into xk plus 1 plus b. And yk you write as yk itself. Next, what is d2? d2 is yk plus 1 minus y. And we know y is, what is y? Y is m into xk plus 1 minus b. So we will get d2 as, yk plus 1 minus m into xk plus 1 minus b. So we got the values of d1 and d2. Now let us find out what is d1 minus d2. Now we are going to find out what is d1 minus d2. So just subtract these two equations. You know the equation for d1. You know the equation for d1 and d2. So just subtract these two equations, and then you will get d1 minus d2 as 2m into xk plus 1 minus 2yk plus 2b minus b by minus 1. I repeat once again, subtract the top two equations, then you will get d1 minus d2. d1 minus d2 will be 2m into xk plus 1 minus 2yk plus 2b minus 1. Okay. Now, what is the relevance of d1 minus d2? My question is that, what is the relevance of d1 minus d2? Okay. Now, if d1 minus d2 is negative, if d1 minus d2 is negative, it means that, it means what? If d1 minus d2 is negative, it means that d2 is bigger than d1. So in that case, we all know that we have to plot the pixel having coordinates xk plus 1 comma yk, because d1 is smaller. Similarly, if d1 minus d2 is positive, d1 minus d2 is positive, it means that d1 is greater than d2. That means d2 is smaller. If d2 is smaller, the next pixel to be plotted is xk plus 1 comma yk plus 1. So that is the relevance of this parameter. This d1 minus d2 is a very important parameter. So based on whether the d1 minus d2 is positive or negative, based on that, we can determine which pixel is to be plotted next. If d1 minus d2 is negative, then d1 is smaller. So next pixel to be plotted is xk plus 1 comma yk. And if d1 minus d2 is positive, It means d2 is smaller. So the next pixel to be plotted is um, xk plus 1 comma yk plus 1. Okay, so this d1 minus d2 is a very important parameter. Now there is one problem. There is one problem. D1 minus d2 is a decision parameter actually, but there's one problem. Here we know that value of m is delta y by delta x. So here in the computation of d1 minus d2, there is a division occurring here. And delta y by delta x will be, there's a chance for delta y to delta x to be a decimal number or a floating point number. So this calculation of d1 minus d2 will involve some floating point operations. And we know that floating point operations are expensive. So as you can see in the computation of d1 minus d2, there is a m, and m is delta y by delta x. So there's a division going on, and the result of this division will be a floating point value. So there is a chance for some floating point operations to occur while we are computing d1 minus d2. So floating point operations are expensive. So to avoid that, what we're doing is we are multiplying delta x on both sides. We are multiplying delta x on both sides. So this m will be, what is this m? This m is actually delta y by delta x. So when you multiply delta x on both sides, this delta x and this delta x will, there's a possibility for cancelling out. Now what I'm telling is I'm going to multiply this term by delta x. And I'm multiplying delta x on both sides. I'm going to multiply delta x on both sides. And when I'm multiplying delta x on both sides, this m, since the m is delta y by delta x, there's a possibility for, we can ensure that when you multiply delta x on both sides, we can ensure that this delta x in the denominator will cancel out and go. That will happen for sure. That means there will not be any kind of divisions, or floating point numbers will never occur, or floating point operations can be avoided. And we can make sure that only integer calculations will remain. Okay. That is the point. So, and we take this delta x into d1 minus d2 as our decision parameter pk. So actually, we can make a decision based on d1 minus d2. But the computation of d1 minus d2 involves floating point operations. So instead of taking d1 minus d2 as the decision parameter, we are actually taking delta x into d1 minus d2 as the decision parameter. Okay, and so our pk is delta x into d1 minus d2. So pk is, this is pk. The value of pk is this. This is the value of pk, and the value of pk can be found out by expanding this m as delta y by delta x. So yes, we have multiplied delta x on both sides to ensure that there is only integer calculations, and also we instead of m in the above equation, instead of m we substituted delta y by delta x, and thus we got pk values delta x into d1 minus d2. Okay, and yes, and one more thing. So we reached till here. We reached till here, and in this equation, this part is a constant. This part is a constant value, because delta y is constant, 2 is constant, delta x is constant, b is constant, 2 and 1 is constant. So this particular term is constant. So you can replace this constant using a variable, or using a constant symbol c. So the equation will become this. So yes, this is the equation now. So pk is, the pk was delta x into d1 minus d2. So instead of d1 minus d2, we substituted the big equation, and we found out some constant values. These constants were grouped together, and instead of these constants, we wrote c. So the final equation for pk is 2 delta y into xk minus 2 delta x into yk plus c, where c is a constant. Okay, so now onwards, we are going to take decisions based on pk values only. And don't worry, the sign of pk will only depend on sign of d1 minus d2, because delta x is anyway positive. I said normally I said in the previous slide that we are going to make decisions based on the sign of d1 minus d2. But pk is delta x into d1 minus d2. But trust me, the sign of pk is same as the sign of d1 minus d2, because pk is delta x into d1 minus d2. So delta x is anyway positive value, because delta x is always greater than 0. So from that we can understand that pk will have the same sign as d1 minus d2. So when you compute the value of pk, depending on the sign of pk, you can make decisions, because the sign of pk will be same as the sign of d1 minus d2. It's very clear from the equation. Here delta x is positive. Delta x, here pk is delta x into d1 minus d2. So delta x is positive, which means that pk's sign will depend entirely on d1 minus d2. If d1 minus d2 is negative, then pk will be also negative. If d1 minus d2 is negative, then pk will be also negative. And if d1 minus d2 is positive, pk will be also positive, because delta x is anyway positive. So my point is this, the sign of pk depends on the sign of d1 minus d2. So we can, so pk is actually, pk, which is delta x into d1 minus d2, is actually a good decision parameter. So yes, I already said c was a constant, and the c was 2 delta y plus delta x into 2b minus 1. So that was a constant. So we replace that constant with c. Okay. Now this also we discussed. If d1 is less than d2, if d1 is less than d2, then pk is negative. So in that case, the pixel at yk will be closer to the line path when compared to the pixel at yk plus 1. So we will plot the lower pixel who has the coordinates xk plus 1 comma yk. Otherwise, if pk is positive, that means d1 is greater than d2, then we will be plotting the upper pixel, which has, what is the coordinates of the upper pixel? Coordinates of the upper pixel is xk plus 1, xk plus 1, comma yk plus 1. So depending on the sign of pk, or indirectly depending on the sign of d1 minus d2, you can make decisions. Okay, now next point. So now look at here. So what is pk? What is pk? Pk is, what is pk? Pk is 2 delta y into xk minus 2 delta x into yk plus c. Okay. Then what is pk plus 1? pk plus 1 will be 2 delta y into xk plus 1 minus 2 delta x dot yk plus 1 plus c. I'll repeat once again. It's very clear. What is pk? Pk is 2. It's very clear. What is pk? Pk is what? Pk is 2 delta y into xk minus 2 delta x into yk plus c. Then what will be pk plus 1? Instead of k, you substitute k plus 1. So pk plus 1 will be equal to 2 delta y into xk minus 2 delta x into yk plus c. That will be pk plus 1. So yes, what is pk plus 1? In that equation that we derived, instead of k, you substitute k plus 1, subscript k plus 1. And then you can get pk plus 1. Pk plus 1 is 2 delta y into xk plus 1 minus 2 delta x into yk plus 1 plus c. The previous equation that we derived was for pk. In that equation, instead of k, you substitute k plus 1, subscript k plus 1. So you will get the equation for pk plus 1 like this. Okay, now what? Now subtract pk plus 1 and pk. Previously, we derived the equation for pk, and now in this slide, we have derived the equation for pk plus 1. Subtract both the equations. When you subtract both the equations, you will get like this. Yes. So we got pk plus 1 minus pk as 2 delta y into xk plus 1 minus xk minus 2 delta x into yk plus 1 minus yk. Okay. Now we know that what is the relationship between xk and xk plus 1? Yes. Look at this. Xk plus 1 will be equal to xk plus 1. Because we know that at each step, the x coordinates will increment by 1. So xk plus 1, that means the x coordinate of the next pixel to be plotted will be equal to x coordinate of the previous pixel that is plotted plus 1. So this equation is valid. Xk plus 1 will be equal to xk plus 1. That means the x coordinate of the next pixel to be plotted will be equal to the x coordinate of the previous pixel that is plotted plus 1. X coordinate of the next pixel to be plotted will be equal to x coordinate of the previous pixel that is plotted plus 1. That is 100% sure thing. We all know that. So in the previous equation, let us replace xk plus 1 with xk plus 1. That means I'm going to so in the previous equation, wherever you can see xk plus 1, I'm going to replace that with xk plus 1. So I'll get like this. So this is what I get. So this xk and minus xk will get cancelled. And this is what I get. See? This is what I get. Okay. Now what? Now I will take this pk to the other side. So I'll get like this. See? So I'll get like this. So now look at this term. Look at this term. Look at this term. This term you can see yk plus 1 and yk. And we know that yk plus 1 can either be yk itself or it can be yk plus 1. Okay. And when will yk plus 1 be yk itself? Yk plus 1 will be yk itself when pk is less than 0. So when pk is less than 0, yk plus 1 will be equal to yk. That means this term will become 0 when pk is less than 0. So what will you get? Pk plus 1 is equal to pk plus 2 delta y. That is how you find out the next decision parameter when pk is less than 0. I hope you remember the algorithm. Okay. Now what is the alternate path? Now next, yk plus 1, y subscript k plus 1, y subscript k plus 1. That means the next pixel to be plotted will have y coordinate yk plus 1 when pk is greater than or equal to 0. I repeat once again, y subscript k plus 1 will be equal to yk plus 1. Y subscript k plus 1 will be equal to yk plus 1 when pk is greater than or equal to 0. So in that case, this particular term will become 1. So when pk is greater than or equal to 0, this particular term will become 1, because when pk is greater than or equal to 0, y subscript k plus 1 will be equal to yk plus 1. So this will become yk plus 1 minus yk. That is this yk. So this yk will cancel and go. Balance what is remaining? 1. So my point is this: if pk is greater than or equal to 0, yk plus 1 minus yk, this particular term will become 1. Because when pk is greater than or equal to 0, y subscript k plus 1 will be equal to yk plus 1. So at that time, pk plus 1 will be equal to pk plus 2 delta y minus 2 delta x. Okay, I hope you remember this equation. It is there in the algorithm. So yes, the term yk plus 1 minus yk is either 0 or 1 depending on the sign of parameter pk. Whether pk is less than 0 or greater than or equal to 0, depending on that, yk plus 1 minus yk will be 0 or 1. Okay, now we have to derive the equation for P0. That is the last task. Now we all know that the equation for a line is, y is equal to mx plus b, where m is the slope of the line and b is the y-intercept. Now we know that the left endpoint of a line is, x0, y0. So in the equation y is equal to mx plus b, instead of y, I will substitute y0, and instead of x, I will substitute x0. Then what will I get? In the above equation, y is equal to mx plus b. In the above equation, y is equal to mx plus b. Instead of y, I will substitute y0, and x, I will substitute x0, because x0, y0 is the left endpoint. So then what will I get? Yes. Then you'll get like this: y0 is equal to mx0 plus b. So what is b then? From this equation, what is b? Yes, b will be this. Yes. So we got the equation y0 is equal to mx0 plus b. From that, b is y0 minus delta y by delta x into x0, because m is delta y by delta x. So from this equation, we got the value of b as y0 minus delta y by delta x into x0. Okay. Okay, now coming back to this location. So what is pk? So we know that what is pk? Pk is 2 delta y into xk minus 2 delta x into yk plus c. Then what is p0? Instead of k, you substitute 0. So what will be p0? I'll repeat once again. Pk is 2 delta y dot xk minus 2 delta x dot yk plus c. So what is p0? Instead of k, you substitute 0. So p0 will be equal to 2 delta y into x0 minus 2 delta x into yk plus c. Okay, so yes. So yes, we got P0 as 2 delta y into x0 minus 2 delta x into y0 plus c. Now I'm going to substitute for c. We all know, I'm going to expand this c, okay? Yes, on expanding c, I got this equation. On expanding c, I got this equation. Okay, because c was what? C was 2 delta y plus delta x into 2b minus 1. So I expanded c and I got this final equation. Now in this above equation, substitute for b. In the previous slide, see here in the last line, we got the equation for b. Here we know the equation for b. So in this final equation, instead of b, you can substitute that particular formula. Yes, and then you will get this answer. So in this equation, in this particular equation, instead of b, you substitute the formula that we derived in the previous slide, and then you'll get the answer as this p0 is equal to 2 delta y minus delta x. Okay, so that's it. Thank you.